Hi, this is Babak. In this video I'm going to solve the following problem for you. This is a problem in linear algebra on the topic of lines and planes in 3 space. Let me read the problem for you first. Consider the following lines: L with these parametric equations and L prime with these parametric equations. Show that L and L prime are askew parallel and determine a parametric equation of the line that intersects both L and L prime and is orthogonal to both of them. Then determine the shortest distance between L and L prime. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, one possible answer that you will get for parametric equation for the line is written here, and the shortest distance is the square root of 3. Okay, now let us solve the problem. We know that there are 4 relative positions for 2 lines in a space. Either the lines are on top of each other exactly, so it is essentially they are the same lines, even though they might be represented by different equations, or they might be parallel. Parallel means that they do not intersect, one condition, and they lie on the same plane, the second condition. But it might happen that the lines are askew parallel. It means that they don't intersect, but they don't lie on the same plane. And finally, it might happen that the lines are intersecting. So there is only one single point which lies on these 2 lines simultaneously. To show that these 2 lines are askew parallel, one good and possible way is to rule out the 3 other possibilities. We show that L and L prime cannot be the same line, cannot represent the same line. They cannot be parallel and they cannot be intersecting. So there is only one possibility left. This means that L and L prime have to be askew parallel. So that's this strategy that I want to tackle the problem with. Okay? So what should I do? First of all, I want to rule out the possibility that these 2 lines are the same line or they are parallel. So the best thing to do is to look at the direction vectors of L and L prime, which are the components of the parameter t in their corresponding equations. So I would say that, for example, I can say that d of L, the direction vector for L, is actually 1, 2, and minus 3. I am reading the coefficients of the parameter t, and then dl prime, for the same reason, is minus 2 and 1 and 1 again. And then it is clear that these 2 vectors are not parallel. Why? Because none of them is a scalar multiple of the other one. If I want to make 1 equal to minus 2, I have to multiply this by minus 2, but then the problem is that this becomes minus 4, but this is 1. So these 2 vectors are not parallel because neither of them is a scalar multiple of the other one. Okay? So this immediately tells me that dl is not parallel to dl prime, and this means that L is not parallel to L prime and L is not equal to L prime. Okay, because if L and L prime are the same line or they are parallel, their direction vectors have to be the same. Okay, so there are 2 possibilities left. Either they are intersecting or they are askew parallel. How should I realize that if they are intersecting or not? So what I do, I would write a parametric equation of one of them with, say, parameter t. I'm just writing a line L, the equations here. And then L prime, so let me write it with parameter t prime. Yes, because we don't know exactly that these 2 parameters have to be the same. So I would write it as minus 2t prime, and then I would write it as t prime plus 2, and then z t prime plus 4. Okay, and what I do, I will see that if they are intersecting or not. If they are going to be intersecting, there should be one single point which satisfies the equation of these two, yes? So in principle, I need to equate the x values. So I will say that t plus 2 is minus 2t prime if they are going to be intersecting, and then 2t plus 2 should be equal to t prime plus 2, and minus 3t minus 1 should be t prime plus 4. So what I'm saying is that if there is a point that lies on these two lines, because this lies on the line L, its coordinates should follow these rules. And because it is on L prime simultaneously, its coordinate should satisfy these rules. So it means that these should be the same, unless otherwise we will have different points. Okay, so what does it mean? It means that you see I have a system of 3 equations but only in 2 unknowns. So I will use 2 of them to determine t and t prime and check it to the third equation. If it satisfies the third equation, it means that these two lines are intersecting. If not, it means that they are not intersecting, and because I have already ruled out these two possibilities here, then it means that they are skew parallel, and I am done with the first part of the problem. Okay, so it doesn't matter which one I use. For example, here, let me use t here. T is minus 2t prime minus 2, and I put it here in the second equation. Multiplied by 2, it gives me minus 4t prime minus 4 plus 2 is equal to t prime plus 2. So t prime, this is cancelled, then I will get minus 3t prime is equal to 4, yes, and then t prime is equal to minus 4 over 3. So this is my t prime. And then I can put it back in this equation to find t. Okay, so t becomes 2 times t, minus 2 times t prime, which is 8 over 3 minus 2. If I simplify that, t becomes 2 over 3. But I need to check these two numbers in the third equation that I haven't used so far, yes, meaning this last equation. Okay, the left-hand side of the last equation is minus 3t minus 1, but I got t to be 2 over 3, so it becomes minus 2 minus 1, which is minus 3. And the right-hand side of that is t prime plus 4, but t prime is minus 4 over 3 plus 4, so it becomes 8 over 3, and they are not equal. So this means that these two lines cannot be intersecting, so it means that these two lines have to be skew parallel. So L and L prime are skew parallel. This is the first part. But the second part, I want to find an equation for the line that lies on L and L prime, intersects both of them, and it is orthogonal to both of them simultaneously. So if I want to give an idea how, so let me just try to draw a picture, for example. So let us assume that this is the line. So for example, let me just draw them something like that. So this one of these lines is L prime. You need to see it in a space, okay? So apparently this line is going into the page. So for example, if it intersects my page, so it will go beyond the page, something like that, okay? So then this is L and L prime, and assume that this line is the line that intersects both of them, and it is perpendicular to them simultaneously. So if I want to draw something that it's understandable more or less, it means that this is something like that. So, and then let me call this point point A prime, and this point point A. Okay? My goal is to determine the equation of this line. You know that for determining the equation of a line, I need to know a point on my line and a vector that I can convince myself is parallel to my line. but I do not have any of them here right now. Okay, of course there is a way to find the direction vector here. I will discuss it in the second part of the problem, but it will not help. So I mean, I can take the direction vector of this line and direction vector of this line and cross product them, then it definitely becomes parallel to this one and it can play the role of my direction vector. But the problem is that I don't have any way to find a point on my line. So even though that's correct, it's not probably very helpful at this point. So we have to change the strategy. Okay, what can I do? I can say that, okay, this point A is a point on the line L prime, and the parametric equations of the line L prime are these. So I can write that this has these coordinates, minus 2t prime, and then I will have t prime plus 2, and then I have t prime plus 4. And then for A, which lies on line L, I can write the coordinates to be t plus 2, 2t plus 2, and finally minus 3t minus 1. Okay, and I hope that this is clear for you now, that for example, if I have A prime A, yes, so for example, if for example, let us concentrate here this vector. This vector A prime A can play the role of my direction vector. Okay, so how should I write that? I would write that A prime A is actually, let me start from a little bit higher point. So A prime A is the final point minus the initial point. Yes. So then it becomes A minus A prime. So if I want to write it, so I would write this minus that. It becomes t plus 2t prime plus 2. I'm writing them in order. And the second one becomes 2t minus t prime. And the third one becomes minus 3t minus t prime. And then I will have minus 5. Yes, so that is the vector A prime A. But I know that this vector is supposed to be perpendicular to L, so definitely it is also perpendicular to DL, which is parallel to my line. So it means that the dot product between this vector and that vector should be 0. So A prime A dot DL should be equal to 0 because they are supposed to be perpendicular. And of course you have it here. This is DL and this is A prime A. So it means that I have to multiply the first component by the first component, the second one by the second one, the third one by the third one, and add them and equate this to 0. So let us just do that. So the first one becomes 2t plus 2t prime plus 2. The second one becomes 4t minus 2t prime. The final one becomes positive 9t, positive 3t prime, positive 15. This should be equal to 0. So let us simplify this equation. So I have 1t here, 4t, 5t, and then I have this becomes 14t, yes? And then here I have 2t prime cancels, so I'm left with 3t prime. And for the numbers, I have 2, yes, and I have 15. I move it to the other side, so it becomes minus 17. So this is one equation. Yes? Other equation is also clear. A prime A should also be perpendicular to the other line. Should it also be perpendicular to the DL prime? But we have DL prime here, yes? Let me make it a little bit smaller so that we can see it. This is DL prime. DL prime. So I do the same thing. I multiply the first component by the first component, second by the second, third by the third, and add them and equate it equal to 0, yes? So what happens? It becomes minus 2t minus 4t prime minus 4, and then plus 2t minus t prime, and then I will have minus 3t minus t prime minus 5 equals to 0. So let me simplify that. So I have here and here, they are cancelled, so I am left with minus 3t, and then I have minus 4t prime minus 5t prime minus 6t prime, And for the numbers, I have minus 4, and then I have minus 5, which is minus 9. I move it to the other side, it becomes 9. Let me simplify that. Let me simplify it by minus 3, so it becomes t plus 2t prime is minus 3. Yes, so I have two equations in two unknowns. I can simply solve that equation, yes? Okay, so if you want to solve that, for example, you can multiply the equation above by minus 2, the equation below by 3, so it becomes 28t minus 6t prime is positive 34, and I have 3t plus 6t prime is minus 9, and when I add them, I will get 31t is equal to so how much is that? Because I was able to guess that the answers should be minus 1 and 1. It is clear that the answer for t and t prime should be minus 1 and 1. Let me see what I am doing wrong here. I multiplied this by minus 2. Okay, so that's minus 2, sorry. So this becomes minus 28 minus 6t prime, and then this is 34, and then this is 3t plus 6t prime minus 9. When I add them, this side becomes minus 25t, and on the right hand side I will get positive 25, and then it means that t is equal to 1. If you put t equal to 1, for example, in this equation, t equal to minus 1, so t becomes equal to minus 1, and if you put it in the other equation, that also tells you that t prime is also equal to minus 1. Yes? Yeah, we can double check. So t prime is minus 1, I put it here. I move it to the other side, it becomes minus 2, and I divide by 2. Yes, that's correct. So t and t prime are these numbers, okay? Both of them are equal to minus 1. But then when I replace these things back, I can find a prime of a prime a, which plays the role of the direction vector. I also can find, if I put t here, I can find a. If I put t prime here, I can find a prime. Yes? So let us just do it here so that I have enough space here. So a prime, so therefore a prime a becomes equal to, so I'm just putting minus 1 and minus 1 here, so this will be cancelled, it becomes minus 1. The next one, I put minus 1 and minus 1 here, it becomes again minus 1. And then the last one, I put it here, it becomes positive 3. Yes, it is again minus 1. Okay? So this is a prime a, and for example, you can also find the point A. What is the point A? The point A is, I put t equal to minus 1 here, so this gives me point 1, 0, and 2. Okay? So now you can write the equation, but you see that I have written the equation exactly with this point. You could easily choose this point, it doesn't matter. And then instead of minus 1, minus 1, minus 1, I have multiplied this by a negative sign, so that's write it 1, 1, 1. The only thing is that I am looking at a prime as the direction vector, and it doesn't matter actually in which direction I see that. Okay, so what I have written here is completely correct, but if you want to write it with minus 1, minus 1, minus 1, that is also correct, or any multiple of this actually works. And even if you don't like to work with a, you can work with a prime, so that would be a little bit different, but that would be the same line. Okay, and then if I want to find the shortest distance, I hope that you agree with me that this is actually, this length is the shortest distance between these two lines, and then that is the length of the vector a prime a. But the length of vector a prime a can be simply calculated. The norm of a prime a is equal to square root of minus 1 to the 2 plus the other one plus the other one, which is equal to square root of 3. So using this technique, even though it was a little bit lengthy, we were able to solve both problems simultaneously. We were able to find both the equation and the shortest distance. But sometimes the only thing that we are supposed to calculate is the shortest distance. For the shortest distance, actually we don't need to go through this long calculation. So if I want to just find the shortest distance, let me go to the other page and try to draw that picture once more here. So here, this is my L, and this is my L, and I don't know which one I meant. Oh, okay, the above one I'm named L prime, and this one is L. I want to find the shortest distance here. Okay, only shortest distance, not the equation. I don't want, for example, assume that I don't want to find the equation of this line which is perpendicular to L and L prime simultaneously, but I just want to find the shortest distance. So hopefully you can immediately convince yourself of the validity of this argument. So what I do, I choose a random point. There are two ways that I can do it. I think this is the shortest way. So I choose a random point on L. Finding a random point of L on L is easy. So you just give a number for the parameter t, and the simplest one is probably 0. So for example here, if I put 0, I can find a random point called 2, 2, and minus 1. Of course, I don't know exactly the position of this point. I'm just sketching a graph for myself to understand it better. And then I choose a random point on on L prime. So let me call it, for example, B prime, by doing the same thing, giving 0, for example, to the parameter in L prime. Then I will get 0, 2, and 4. And then what I want to do is to find this vector BB prime, for example, and project this, find the length of the projection of this vector to the vector that is perpendicular to these two lines simultaneously. Here, this is helpful. You see, if I go back and find DL, so what was DL? DL is 1, 2, and minus 3. If I ask you what is DL prime is minus 2, 1, and 1. If I cross product them, so you see DL is a vector parallel to this one. This is, for example, the air in which direction I don't know. What is the length? I don't know. We don't care. But then, for example, this is DL prime. So this is parallel to L prime. This is parallel to L. If I cross product these two vectors, it becomes a vector which is simultaneously perpendicular to DL and DL prime. So it means that it becomes parallel to this line that I want to find its length, because this line also is perpendicular to L and L prime simultaneously. So let me just repeat. DL cross DL prime would be a vector which is perpendicular to DL and DL prime simultaneously. This line is also perpendicular to L and L prime simultaneously, but DL is parallel to L, DL prime is parallel to L prime. So DL cross DL prime would be a vector parallel to this. And if I project this vector on that vector DL cross DL prime and measure the length of that projection, this will give me the shortest distance. Okay? So what I am saying is that the shortest distance is equal to the length of the projection, orthogonal projection of the vector BB prime on the vector DL cross DL prime. And of course, if let me just write the formula here for you. So if you have a vector, for example, v, let us call it v, and then you have another vector u, if you want to find the length of the projection of u on v, so the projection of u on v, if you are interested in calculating the norm, you have seen it in your linear algebra course, this becomes the fraction whose numerator is the absolute value of the dot product between these two vectors, and the denominator is the norm of the vector that you want to make your projection onto that. Okay, so here my goal is to project this vector onto this vector. So the shortest distance according to this formula becomes a fraction whose numerator is the absolute value of this vector bb prime by that vector dl cross dl prime, and then you divide it by the norm of the vector that you are projecting onto it, means the norm of this vector. Okay, but hopefully you see that this is not complicated actually to calculate. So what I want to do, I go back here and calculate dl cross dl prime. So what I do, so the numbers are like determinants, I calculate like determinants, yes, so it becomes 2 plus 3 is 5, and then the next one is 1, minus 6 is minus 5, but there is an extra negative sign here, so then the last one becomes again 5. Okay, and of course if you want to, you can divide by 5, it becomes 1 and 1 and 1. And by the way, let us go back and compare with the previous solution. So do you remember, we got this vector as this vector, and you see this vector is parallel to the vector that I am getting here. Okay, so if you want to, you can rescale this, because rescaling this, the only thing that it will change is the length of this dl prime is, for example, some number, and I divide it by 5, it becomes a shorter number. And it doesn't matter if I am projecting this one on a shorter vector or on a longer vector, so the projection would be the same. Okay, so yeah, so let me just do that. So let me define n to be 1 and 1 and 1 by rescaling it. So then let me write this formula in this way. So this becomes equal to the absolute value of bb prime dot n divided by the norm of n. Okay, it doesn't matter, of course, you can work with that number, but this is easier. And of course the norm of vector n is equal to square root of 3, 1 plus 1 plus 1. And what I need to do is to calculate bb prime, which is easy here, so let me write it here. bb prime is the final point minus the initial point. So it becomes 0 minus 2, which is minus 2, 2 minus 2, which is 0, and 4 minus minus 1, which is 5. So what I have to do, I have to write it as absolute value, minus 2, 0, and 5, dot product with 1, 1, and 1, divided by norm of vector n, which is the square root of 3. But in the numerator, I will get minus 2 plus 0 plus 5 divided by square root of 3. The numerator becomes 3 divided by square root of 3, so it becomes a square root of 3, and that is actually the same number that we got there. Yes? Even another way to find again the shortest distance between two skew lines is that I want to describe it here. So let me just do that here. So for example, again, I will have this point, this line L prime, and then this is L. So what I do, let me make it shorter this time. So this is my L. This time I will try to find an equation of a plane that contains the whole L and is parallel to L prime. Okay, so it means that I want to first find the equation of this plane that contains L and is parallel to L prime. For writing an equation of a plane, I need a point that is on my plane, and I need a vector which is perpendicular to my plane. Okay, from a point of view, I don't have any problems because any point that is on this line is already on the plane. And so it means that I just pick a random point from this L. So let us just choose the same point B as before, yes? So by putting 0 in this T for equation of the line, so it becomes 2, 2, and minus 1. Okay, so that's one point. And then again, I hope that you can convince yourself this is the vector, for example, dl, and this is something for dl prime. And then you know that if I cross product them, it becomes exactly the normal vector of my plane. Yes? So, and that is exactly in that I got it before. Of course, dl times cross product dl prime was 5, 5, 5, but n also works for me because if dl cross dl prime is perpendicular to the plane, n is also perpendicular. So what I need to do, I would write it like this: n is equal to 1, 1, and 1. And then what I can do, I can write the equation of the plane. So it is ax minus x naught plus b times y minus y naught plus c times z minus z naught is equal to 0. So instead of a, b, and c, I put 1. Instead of x naught, I put the x coordinate of b. So it becomes, the other one becomes this, and the other one is minus 1 z minus, sorry, this is 1 again. This is 1. And then I have z positive 1 equals to 0. If I simplify that, it becomes x plus y plus z minus 3 is equal to 0. Okay? And then hopefully you can convince yourself again that if I find the distance of any random point from the plane, not from the line, all of them are equal to this shortest distance that I want to find. So it means that I will go and find a random point on L prime. So for example, that B prime is okay. By putting T equal to 0, I will get 0. I will get 0, 2, and 4. And then I find the distance of this point from this plane. So hopefully you know this formula, yes? If I want to find the distance of a point from a plane, let me write it here for you. Assume that you have a plane. Assume that you have a plane of this equation. And then you have a point whose coordinates are x naught, y naught, and z naught, and you want to find the distance, let us call it h, from that point to the plane, then the formula is this. Yes? So it means that I replace x, y, z in the equation with the x, y, z coordinates, and then I divide by square root of a squared plus b squared plus c squared. But of course, if you want to see why the proof is that, this is exactly the projection, the length of the projection of that line onto the normal vector. So you can just do it in that way, but I would prefer to do it shortly like that. So then the shortest distance that I am looking for is equal to, I replace x and y and z with these numbers. So it becomes 0 plus 2 plus 4 minus 3. And then in the denominator, I will divide by square root of the coefficients of x, y, and z squared. But then in the denominator, you get square root of 3. In the numerator, you get 3. And then again, this becomes a square root of 3. So that's also another way to calculate the shortest distance. But you need to convince yourself of the geometry. Why, if we draw, if we consider a plane that contains one of these and is parallel to the other one, and if I measure the distance of any random point from this plane, it becomes exactly that shortest distance between these two lines. Of course, that is not hard to convince yourself. but you need to think about it. Okay. Below this video you will find the link to the PDF file of these notes. I hope that this video is useful for you. Until the next video, be safe and goodbye. Thank you.